Okay, so today we're going to cover lesson 1-7, and we're going to learn a problem-solving plan. So this is going to be a plan that you can use. It's a 5-step plan whenever you're trying to solve a word problem. So step number 1 tells you to read the problem carefully. Okay, decide what unknown numbers are asked for and what facts are known. Sometimes drawing a picture could help you, especially next year when you take geometry. If a picture is not provided, draw one. A lot of times in geometry, you're going to get word problems. And the same thing here. They might ask you about the area of a room, and it might say a rectangular room. Maybe you're going to carpet it. So I would always draw a picture. Generally, the last thing, so step number 1, you're going to read it carefully. Generally, the last thing in the paragraph or the problem is going to be your unknown or your variable. Okay, so then step 2, you're going to choose a variable, and you're going to use it with the given facts to represent the unknowns in the described problem. And again, you can choose whatever letter you like. I like X or N. Sometimes when you pick the letter T or the letter S, the T might look like a plus sign or an S might look like a 5. However, you can use whatever letter you want to use for your variable. Then step 3, it's going to tell you to reread the problem and write an equation that's going to represent the relationship. Then step 4, we're going to solve the equation for whatever unknown it was, the variables. And then step 5, you're going to check your results with the words of the word problem to give your answer. And always remember, if your answer is going to involve units, to label them clearly. Especially when you start geometry. If it's area of a room, you need to put it in inches squared. If it's volume, it would be inches cubed. If it's a problem involving money, make sure you include the dollar sign. So whatever units are involved, make sure you clearly include those in your answer. So just a strategy that you can use to solve word problems. So here is our first example, and it's the example from the book. There's only one example here. So it's telling us to use the 5-step plan. It wants us to write out each step, and it's giving possible answers. So this possible list of answers here is called the domain. Okay, it's what they want us to try to plug in to our variable that we defined. So the first thing I'm going to do is I'm going to read my problem. Okay, step number 1. So it says, Philip has $23 more than Kevin. Together, they have $187. How much money does each have? So notice in my given domain here, it's telling us that the choices for Kevin's amount are either 72, 78, or 82. So that should be a clue right here when they're giving you a domain that I'm going to let my variable represent Kevin. So I'm going to define that Kevin is equal to X. And again, you can choose whatever letter you want. Then I'm going to go back and I can see that Philip has $23 more than Kevin. So for Philip, I am going to let Philip equal X plus 23. And then now I need to come up with my equation. It says together they have $187. So what would the word together tell me I'm going to do with the variables I just defined for Kevin and Philip? Add them. So together, so Kevin plus Philip, and you can put it in parentheses or you really don't need to in this particular problem, and it says together they have $187. So I've reread the problem. I found my equation that I'm going to use, and that will represent the relationship between the quantities. So now that I have my equation, technically we have not learned how to solve equations, so I'm now just going to use the domain that's given, and I'm going to plug in and do the problem 3 different times until I find the answer. All right, so when you're doing these in your homework, I want to see you define each one of the unknowns, write an equation, and then you're going to show me how you're replacing each one of the amounts that are given. So for example, I'm going to first start with 72. So I'm going to take 72 plus 72 plus 23 equals 187. So over here I'm going to do it vertically, 72 and 72. I'll do 2 at a time. 144 plus 23, and I get 167. 167 does not equal 187, so I can see that that choice in my domain is out. Now I'm going to try 78. 78 plus 78 plus 23 equals 187. So 78 plus 78, 6, 156, plus 23, 179. So 179 is not equal to 187. So that option in my domain is also out. So one more to try. So I'm going to do 82 plus 82 plus 23 and see if it equals 187. 82 plus 82 is 164 plus 23 gives me the 187 that I need. So 187 equals 187. So here I can see that Kevin, his amount is $82. And then to find Philip's amount, I need to take 82 plus 23, and I find out that Philip has 105. And again, make sure you label that these were money problems. So in your homework tonight, I need to see how you're defining the variables, writing the equation, and then the work for replacing each number from the domain and showing it. And then you'll finally write your final answer with the correct units, showing me how much each person has. Okay, so I'm going to do number 10 from your homework. And again, I'm going to read the problem first. I'm going to follow step 1. Step 1 says to read the problem carefully. I'm going to decide what unknown numbers are asked for and what facts are known. So it says Western State College is 18 years older than Southern State. Western is also 2.5 times as old as Southern. How old is each? Now, notice again, in my domain here, the choices for Southern State are going to be 12, 14, and 18. So right away, I am going to decide that Southern State, and I'm just going to put Southern, is going to be my X. And now I'm going to go back and reread to see what Western is going to be. So Southern is going to be my X. Western, I'm going to go back to the beginning now. I've chosen my variable, and now I'm going to reread. So Western State College is 18 years older than Southern. What do you think older means? What kind of operation? Addition. Okay, so for my Western, I'm going to set it up as 18 plus x, or 18, or x plus 18. The order here doesn't really matter. But notice now, as I continue reading, they're giving me some more information about Western. And it says Western is 2.5 times, is also 2.5 times as old as Southern. So this one's going to be set up a little bit differently. So I'm going to again write what Western equals. And this time it says it's 2.5 times Southern. Now, instead of doing an operation with the x and the x plus 18, because I don't know how much the total is, I just know here that the red Western expression that I wrote and the blue, these are the same amounts. So for this problem, I'm going to set the two quantities I have, or the two expressions for Western, I'm going to set them equal to each other. So I have x plus 18 is equal to 2.5x. Now, at this point, when I start trying to replace my domain values, I can leave it like that. I can also make 2.5 a decimal, but I'm going to make my 2.5 an improper fraction. And it'll be a little bit easier because that denominator 2 will simplify. So I'm going to actually change 2.5 into 5/2. This side I'm leaving alone. So now that I have my variables defined and my equation that I'm going to use to solve, I'm now going to take my 3 domain values and I'm going to start replacing them until I find the one that works. So I'm going to start with 12. So 12 plus 18 is equal to 5/2 times, and I could put 12/1. The reason why I made it improper, look how nice this goes into here. And then I'm going to multiply 5 times 6, and then 2 times 1. So then this side is 30. And then 12 plus 18 is also 30. I've just found the one that works. So now that I found the one that works, Southern is 12, but Western, I now have to take the 12 that I just found that works and plug it into the Western. Now, I can either choose to plug it into the x plus 18, or I can plug the 12 into the 2.5x. So here, to find the value of Western, I would do 12 plus 18, and I would find out that Western is 30. So up here, you're going to write that Southern is 12 years old, and Western is 30 years old. Now, if the first one didn't work, then you're going to go back and you would try 14. If 14 didn't work, then you'd go back and plug in 18 until you find which one of the domain values will satisfy and solve this problem. When you're solving these word problems, I don't want a different variable for Southern and a different variable for Western. You have to use the same variable throughout your equation, okay? Because when you have two different variables, it makes it a little bit difficult, okay? We're going to learn later on how to solve system of equations. But for now, we're only using one variable, and then we would manipulate it for our other unknown throughout the problem. Everybody good? All right, I want everyone to try number 1 on your own, and then we're going to go over it together. Your homework tonight is going to be section 1-7. It's 1 through 18 all, so it's all of the problems. So right now, let's try number 1. Give you guys a few minutes to work it out, and then we're going to work it out together. Okay, so for number 1, the problem says an oil painting is 16 years older than a watercolor by the same artist. The oil painting is also 3 times older than the watercolor. How old is each? And then notice it says the choices for the watercolor's age are 4, 8, and 12. So again, it's giving me my choices for watercolor, so that's what my variable is going to represent. Then I'm going to go back and I'm going to read what it says about the oil painting. And it says an oil painting is 16 years older than the watercolor. And then it also says that the oil painting is also 3 times as old. So we're going to set this one up very similar to what we just did in number 10. So notice we have 2 expressions for the oil painting. So again, I'm going to set them equal to each other. And now I will take my domain values 4, 8, and 12 and start replacing. So when I first try 4 and replace it, notice I get 12 equals 20. That one does not work, so that's out. So then I'll try the 8. 3 times 8 equals 8 plus 16. Notice this one, it does work. So my answer here is 8 works for the watercolor. So again, you're going to say watercolor is going to be 8 years old. An oil painting, I can take either one of these and either do 8 plus 16 or the 3 times 8. Either way, I find out that the oil painting is 24 years old. So when you're doing the homework tonight, I want to see how you're defining the variable, the equation, and then the work for plugging it in until you find the one that works. Once you find the one that works, you can stop, okay? But you have to show how you replaced it, okay? And then you're going to clearly label your unknowns. So here there were 2 unknowns, and make sure you label it with the correct units or whatever the unknown is. And in this case, this was how old the paintings were.